Hello and welcome back to the give back video for the Remove Forces of Motion exam. We're right in the middle of this give back, and at the moment we're on question 9, which is all about converting units from familiar units, newtons per centimetre squared, into the unfamiliar units of gerbils and tails. Now, I realised on the tail end of the last video that I made a slight mistake with getting a fraction the wrong way up, so therefore I'm just going to do it again now and try and get it right this time. The units that we're given are newtons and centimetres. So we're told that the gerbils use these units, where one gerbil is 0.4 newtons and one tail is the same as 5 centimetres. And we're asked to convert from units of 10 newtons per centimetre squared into the new units. So what we're going to do is we're going to multiply by 1, which means that we're not changing it. So one version of 1 that I'm going to use is the gerbil per 0.4 newtons. So I've just rearranged this equation. That divided by that must be 1. And the second version of 1 that I'm going to use, rearranged in this equation, 5 centimetres per tail. And it's still 1, of course, if we square it. So that means I've got 10, collecting the numbers, 1 over 0.4, and I've got 5 divided by 1, but not forgetting that that's squared. And then just collecting the units, I've got my newtons per centimetre squared, which were the units we wanted to get rid of, times by the gerbils per newton, and times by the centimetres squared, of course, divided by tails squared. That means that my newtons is going to disappear and my centimetres are going to disappear. So I'm going to be left with the gerbil per tail squared, which is exactly what I want. And over here on the left-hand side, where I've got my numbers, I'm going to be left with 1, 10. 1 divided by 0.4 is actually 2.5, and 5 over 1 squared, so that's 5 squared, so that's 25. So 25, that's 625. So 62.5 times 10, which gives me 625 gerbils per tail squared. So the right answer here is A. Okay, over the page. This question is about momentum. First of all, we're supposed to state the principle of conservation of momentum. So very simply, momentum before is always the same as momentum afterwards. 1 mark for that. We've got a truck of mass 100 kilograms going at 20 meters per second towards a stationary truck of mass 300 kilograms. So here's our truck with mass, I don't know whether you can see it on there, 100 kilograms, and it's going at 20 meters per second. So the momentum of that truck, P equals m times v. So the mass is 100 kilograms times the velocity, 20 meters per second. That gives us 2,000 kilogram meters per second. Slightly funny unit, of course, for momentum. So again, we've got 3 marks here. The marks are for the equation, the answer, and the unit in this case. What's the momentum of the system after the collision? Well, we immediately know, because the momentum before is the same as the momentum after, it's got to be the same. So that's 2,000 kilogram meters per second. 1 mark for that. Finally, we're supposed to work out the final velocity of this combined truck once the two have stuck together. So we've got 1 coming in from the left, they stick together and they go off presumably a little bit slower. So what is the final velocity? Well, rearranging the equation, that gives us V is P over M. The momentum we know is 2,000 kilogram meters per second, and the combined mass of this truck, so we've got 100 kilograms over here on the left, and this truck on the right has a mass of 300 kilograms, as it tells us there in the question. So the combined mass is 400 kilograms, and that means 2,000 divided by 400 gives us 5 velocity, so it's 5 meters per second. The marks here you could have had a mark for stating this again, or using that fact. So using conservation momentum to get us to 2000. A mark for working out the combined mass of 400 kilograms, and then answer and unit for 4 marks. In question 11, we've got a situation involving a skydiver of mass 70 kilograms. So we've got to figure out what's going on here. The vertical velocity is going up, and then it stops and stays at the same velocity for a while, and then it goes down and reaches a second lower constant velocity before he stops right at the end. So at the end, it's when he hits the ground. So we're asked, at A, the skydiver has an acceleration equal to the acceleration due to gravity. What's the resultant force? So force is mass times acceleration. We're told the mass of the skydiver is 70 kilograms, and their acceleration is due to gravity, so it's 10 meters per second squared. So that means that they've got 700 newtons acting on them at this point. The marks here, 4 marks, so we've got equation, sum, answer, unit. How can you tell from the graph that in B to C the resultant force is 0? Well, the velocity is not changing. Because the gradient is 0. The acceleration is therefore 0 because the velocity is constant. We know that acceleration is change in velocity over time. So if change in velocity is 0, that means acceleration must be 0. And therefore net force, because of F equals ma, if the acceleration is 0, the force is 0. So these two things combined for the second mark. Then we're supposed to describe and explain the motion of the skydiver from C until he reaches the end of T. So at C, we can see that he's slowing down. Why might that happen? So at C, he opens his parachute. Therefore, surface area goes up quite a lot, and that means drag force also goes up quite a lot. So 1 mark for explaining that. The velocity decreases from C to D. That means drag force decreases. That's worth a mark. Then at D, or just after D, force is balanced again, meaning that we've got a second lower terminal velocity. 1 mark for that. And then at E, he lands. The ground pushes up on him, and that's a reaction force. So he stops. And 1 mark for that. So there's our 4 marks. Now, for the final part, a skydiver of the same mass goes from the same height, but has a parachute with the largest surface area. So because he's got the same mass, presumably he's going to accelerate at the same rate to start off with. But then, if he's got the same mass, it's going to take a little bit longer for the for his velocity to be equaled, for the drag force to equal his weight, because his weight force is going to be larger. Then presumably he's got a larger deceleration, so that's going to be steeper there, and then he's going to end up with a lower velocity at the end. So that's his motion. 1 mark for the steeper deceleration after point C, and 1 mark for the lower velocity. Finally, the last question. Now this question was quite hard. We didn't include it in your final percentage. But we're asked to work out the velocity time graph for B relative to car A. So if we just look at car A, if we add on, so let's put some sort of scale onto the graph here. So if we have 0 at the beginning, and then we've got 5, 10, 15, 20 meters per second, minus 5, 10, 15, 20. If we look at car A, it's going at 2 meters per second for 10 seconds. So it's actually going